Hi, in the last video we covered in depth on polynomial regression. In this video we're going to move into dealing with nonlinear relationships but using ensemble method. So let me just walk through this example here. We are importing the so-called standard libraries that we need. We need NumPy, Matplotlib, Seaborn, as well as pandas, and also plot, Matplotlib, basically plot inline. So we're importing the Boston dataset directly this time around from scikit-learn, and we store that in the data frame itself. We're just basically storing the feature names as our column heading. Okay, so basically these are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 independent variables that we've seen before. As for the target variable, we're storing it into Y itself. Rather than importing directly from the actual data that we downloaded, we're just going to make use of the scikit-learn data sets this time around. So these are really a very brief introduction to some of the tools here, tool sets that we will go into depth a little bit more. We're going to cover decision tree and a little bit of random forest, a little bit of AdaBoost, and then we will actually come back to them in future lessons. I just want some continuity here so that you can see that we've been building and working on the Boston housing dataset, looking at correlation analysis, simple linear regression, and then build upon it using a robust regression, and then evaluate our model performance. And then after that, we built on top of that using multiple linear regression, having moved away from simple one-factor regression, linear regression. We moved to multiple linear regressions. And finally, we look at regularization as well as polynomial. We're moving into the space of nonlinear features now. So we're going to look at decision tree, and this is the steps. I just want to first introduce it to you now, and then we will actually revisit that a little later. So we're going to import from scikit-learn, from the tree, the decision tree regressor. We're just going to look at one variable this time around rather than all of the so-called independent factor or the predictor. So we're just going to use LSTAT. From previously we looked at this and we know that it is actually not linear. As for the tree, we do need to set a hyperparameter of maximum depth. Now this is a number that we don't know, so we're going to just try a number 5 just to actually start with that and then work from there. Alright, so having set the hyperparameter, we fit our model using mean square error and maximum depth of 5, and here we're just gonna sort the ID so that the so-called X is actually flattened. We want to sort that out because otherwise our scatter plot and also our line plot is going to be all over the place. So this is just really for plotting purpose. So this is the figure setting the actual fixed size to 10 by 8 and scatter diagram, and also we're plotting the so-called decision tree on top of that just to see what it looks like. The color we set it to black, and we label the x-axis is our LSTAT, and the Y label is our median housing value. So having a look at this, notice that LSTAT is on this side, MATV is on that side. You can see that maybe, well, we definitely have overfitted. This up and down splash here basically tells us that our model is overfitted to the data itself. So we do need to tune our hyperparameter, reduce the maximum depth. That's one of the challenges that you have with decision tree, is that you don't know how many tree to know to actually set, what is the maximum depth to set. So you kind of have to do a trial and error like this. So we're going to try and reduce it down to 2 and repeat the same process again. This time round it looks better than before. You can later on as an exercise try maybe 1 or maybe 3 or maybe 4. That's really an iterative process just to see how it works out. One of the challenge of using decision tree really is that you kind of have to reiterate or iterate through this process to figure out what works best. So instead of doing that, we can make use of an ensemble method called random forest, where it would actually tune for you. And instead of doing one variable as we did before, which is using lstat, we're just gonna feed everything in and let the random forest actually figure that out for us. The slight variation is that we're going to use a matrix selection of train, test, splitting our data to training set as well as the test set, and we're going to import mean square error and R-square as our performance evaluation. The X is really all of our independent variable, and this is the splitting. We're splitting our test, giving 30% to our test size and using 70% to build our model. So this is the next line is really importing our random forest regressor and instantiating it. The criterion we're using is mean square error, and fit our forest, and we're gonna run the actual prediction using the training data, and again run the prediction on our test data, except that these are data that we have not seen before. The test, which is the X test, we didn't use for in our fitting or our training of our model itself. So let's look at the performance of the model now, the mean square error for both in sample and out of sample. In sample meaning during the training period, out of sample meaning during the test period itself. Okay, so the mean square error is smaller during the training period. In sample, under the test, it's actually worse. This is what this is to be expected. It's quite often like this. And have a look at the R-square. Yes, it's the same, 97.87 and 87.39. Again, like I mentioned before, this is really a brief introduction so that you can actually start to be familiar with random forest ensemble method. Another ensemble method that I just want to introduce you to this time around is the AdaBoost. Again, AdaBoost is actually an ensemble method as well. Again, we're just gonna instantiate it, fit the data, and we're gonna predict in sample and run the prediction out of sample, and basically have a look at our mean square error. Okay, notice that the mean square error of AdaBoost is slightly worse, both in sample and out of sample. And having a look at the R-square itself, again, in sample is better than out of sample. So 94, so AdaBoost did not perform as well as the random forest. There may be a few hyperparameters that we need to actually tune. All right, so might have to increase our estimators. There's also other hyperparameters that you can actually vary, maximum depth, other things such as OOB. So this is really just a brief introduction of this. We're gonna go into explaining the actual intuition of the model, under what circumstances does it work best. So we're gonna go into that a little bit more in the future video. With that, I'm gonna stop this video now. Just as an exercise for you, I'd like you to try out what we mentioned before, changing the actual max depth. We've tried 5, we've tried 2. I'd like you to pause the video, try 1, 3, and 4, and see what it looks like, see if it actually improved. Although we don't actually have any performance evaluation matrix that's calculated, if you want to, you can actually try that out as well. With that, please pause the video. When you come back, I'm going to summarize the lesson. I hope you found that exercise useful, just to actually get an initial intuitive understanding of the decision tree. In this video, we've covered decision tree, we've covered random forest, and we've also covered AdaBoost. Although we haven't gone into details on each and every one of these ensemble, they are in a separate section that we're gonna go into depth in explaining how the model works, how is it built, and the actual intuition behind it. I just want to give you in this portion of the lecture under regression, just as a taster for you to actually appreciate that there are other methods out there apart from linear regression, polynomial, as well as robust regression to actually model your data. You can use these ensemble method. Okay, so with that, I'm gonna stop this video. In the next lesson, we're gonna look at how to select features that is important. Okay, so that's really the feature importance, although we actually have covered this in the past under a separate section using correlation analysis as well as feature selection. In the next video, although it's a short one, I'm just going to cover some features that AdaBoost provide as well as Random Forest provides that helps you to actually select important features. So I'll see you in the next video.